Hi, welcome back to the class number 3. This is about state space search. This class is about advanced artificial intelligence. So I'll take you through the class. First of all, any problem in the artificial intelligence domain can be solved by searching, and the searching can take place through status, and moving from state to another state should be done through action or series of actions. So, and then we try arrive at the goal by having started from initial state to the goal state through these actions. An example of this one could be location to room A, or disposition, or holding an object or moving an object. Now, moving from one place to another place can be done by operators or actions. So moving from A source to B should be by actions, and the source is a state, and B is the next state. So in the goal-directed agent, earlier we talked about agent starts at the initial state and takes through actions, and again, through the actions, it changes state from state to another state until it arrives at the goal state. Now, S is a set of states, S dot is initial states, A is set of actions, and G is a subset of state. So G is kind of subset of state. Now, plan, we have sequence of actions. You could have A dot to AN, and you could have state S dot to SN. To find the cost of the problem or path cost, we need to find the actions that we have taken. So some of the actions will be the total cost of finding the problem. So if you have a case whereby action move A to B, it costs you 2 units, and moving B to C, it costs you 3 units. Total cost of the path, 2 plus 3 equals 5. Here, state space, you might have these nodes. The state can be represented by nodes, initial states, goal states, and then there are actions to take to arrive at the goal states. So initial states, you can start from either this branch or that branch, and then move to this branch or that branch until arrive at one of the goal states. Here you found the goal states as you done. So graph representation, you have states, nodes, and nodes represent the state that has all the informations. Could be distance, could be the units, could be the actions as well. And then actions can be edges to move from one node to another node. So that's the goal. S dot is initial states, and goal is the target states. So if we are in the step 1, we are in the current state, and take action, go to the next state or successor state, takes action, and explore more until arrive at the goal. Start with the current state, generate successor states, select one state to explore, check if it's a goal. If not, repeat the process until you find the goal. You might have search trees, and you might have breadth first search, depth first search, greedy search, a asterisk search, and others. So here is the tree. Every diagram or every figure in the search problem can be represented in a figure, and then later on change that figure to a tree, and from the tree we will solve the problem and represent the problem and then solve it. Here we have a pegs and disk problem representation. So if we have 3 pegs and 3 disks, these are common AI artificial intelligence problem. Goal, move all disks to peg B. And rules, move 1 disk at a time. That's the business rule. And move only top disk, because that's the restriction. No larger disk or smaller disk can be there. Now here, example solution, we can move one possible solution, move A to C, move A to B, move C to B, and you might go through some moves until you found the problem. That's the initial state. And then this is the initial state, and for example, this is the initial state and this is the goal state. So here move A to C, and then move A to B, and then move A to C, and then move B to A, and then move C to B, and then move A to B, and then move C to B, and finally is the goal. So that's the basic problem steps to find the solution. We start with the initial state, and then we did the goal state. So here we have the key concept conclusion is that we have state configuration of the world. Operator will take action so that we can move from one state to another state. We start to represent problem by having the initial state and the goal state and the plan of action. And then any figure or diagram, we change it to a tree, search tree, and stay tuned with the next class so that we can have a better understanding and we solve problems using those blind search algorithms. Thank you very much for this class.